Okay, we are going to start by looking at the Unit 4 intro. So basically, I'm not expecting you to be an expert on this stuff by the time I come back on Monday, but there is some stuff that you need to take away from today that you kind of have a general idea of so we can start talking about it next week. Um, Unit 4 is all about graphing quadratics. And so quadratics are what we've been talking about through all of Unit 3. We should feel pretty comfortable about solving them. Square root method, factoring, quadratic formula, those are all different ways that we can solve. And solving them, what that's going to allow us to do is figure out our x-intercepts when we go to graph here. So it kind of is all intertwined with one another. For today, we're just going to be looking at the graphs of these quadratics, which are called parabolas. So we'll be looking at a set of parabolas and trying to determine a few things. The domain and range, those are things that we've already talked about this year. So we'll get to that. We'll get a little bit of a reminder on there, and then once we get to it, we can hopefully um, get those figured out pretty quickly. And then with the new ones, we're going to have interval of increase, interval of decrease, and the vertex. These three things are new to this year, but they are not new to you completely. You would have seen them in Algebra 2 last year. And so hopefully, as we go through this, it's just kind of jarring your memory a little bit, and it's not anything that's going to throw us off too much. So when I look at this first graph, the first thing I'm going to look for is the vertex. That's always going to be the first thing we're looking for. There's a lot of things that we can use the vertex for as we start working through these problems. And so I am going to specifically point out this one right here to start. I can see where it's at. It's at that point 4 over 1 up, and all they're asking for is that location here. So 4 comma 1 is going to be our vertex for this one. Pretty easy to pick out. The next thing we're going to talk about is the domain. And we've talked about this already to this point this year, so we should feel okay about it. But remember, the domain is going to be the list of possible x values. So as I go across on my graph here, I can see that all of these x values between here and here are contained on my graph. So those ones should be pretty obvious. But we also have to remember that there are arrows here. And so the arrows are going to allow us to take that graph and show that it's never going to stop. So going left, it's never going to stop, and going right, it's never going to stop, which means that our domain is going to be negative infinity to infinity. Remember the difference. The vertex is talking about a point specifically. The domain is talking about a set of numbers. The set of numbers will be negative infinity to infinity because, again, it's never going to stop. A quick reminder that we're going to use parentheses here because we can never actually reach those numbers. Negative infinity and infinity are both just kind of concepts. They're not actual numbers. And so they're not approachable, or we can't reach them ever. And so we're going to do the same thing with y, where we'll typically start the y here. And we can see on this one, if I go up and down, that in this case, the arrows are pointing almost straight down. Now, they're not straight down, but they're pretty close to it. I should be able to tell that with my range, I'm going to approach negative infinity. There's no stopping those arrows. But as I go up, we eventually get to this point right here where that's the highest possible point that I can reach on my graph. So that's going to be the second value of our range, negative infinity to positive 1, the same number that we had that went along with our vertex. And because it is a filled in circle, that means that it's included. And so we should put a bracket there. So the first one had, make it a little bit more defined of a bracket. The first one had parenthesis, parenthesis. The second one had parenthesis, bracket. The cool thing is, with parabolas, domain is always going to be negative infinity to infinity. The range will just be negative infinity up to a number, or it will be starting with a number and going up to infinity. So 3 of the 4 things that we write down are going to have infinity involved with them for domain and range. Now, the new concept, new to this year at least, is interval of increase and interval of decrease. So interval of increase is going to be, if we want to think about it like slope, it's when we're going up. So as we move from left to right, like we would normally read a graph, we are going up with our y value. So as the x value increases, the y value increases. Interval of decrease is just the opposite. As I go from left to right, so I go this way, I end up going down. Down and decrease would go hand in hand in this case. And so with this one here, there's two clear or distinct different areas on this one. I can see here is the first one, and here is the second one. Clean up our graph a little bit, but we should be able to see those two areas there. And so with this, if I go right down the middle, right at my vertex, that's the two different areas of this graph. Okay, they say right here that the vertex is the turning point. That's also going to be when we change over our interval of increase and our interval of decrease. And so, because this first part is going up, I normally like to take a highlighter. Oh, that didn't really cooperate, but I like to take a highlighter and draw my interval of increase. Not sure why it's doing that, but I think it's trying to read the graph for us. There we go. Our interval of increase, because as I go from left to right, as I was saying before, so I go over one, I have to go up to get to my next point. I go over one, I have to go up to get to my next point again. So the interval of increase is going to be written just like our domain. It's going to be talking about the x values for which we're increasing. And so my interval of increase is going to be from negative infinity to the x value of my vertex, which is going to be 4. Now it's kind of tricky because the point itself is included, but the interval of increase itself is between negative infinity and 4 for our x values. Okay, so what that means is that once it gets to 4, it's neither going up nor is it going down. It's just it's even at that point. So until I get to 4, I'm going to be increasing. Once I get to 4, I'm not going up or down, and then after or past 4, I'm going to be decreasing or going down. And so I can see that here as I move to the left. Once I get to that vertex point, if I go, or sorry, once I move to the right, I go right, I have to go down to get to my next point. I move over to the right again, I have to move down to get to that next point. So we'll see if this cooperates with us on this one. Not quite. I think we get the idea here, though. So our interval of decrease, there we go, will be going down in that direction there. And again, I'm just going to pick out the x values. So the x value is going to be anything after 4 into infinity. And so that, again, that vertex has a lot of meaning to us in this problem. But the big things we have to remember when we're talking about interval of increase and decrease is we're only talking about the x values. So I'm going to go through the second one, and I'm going to go a little bit quicker this time because we don't need to explain everything. We just need to kind of practice it. So I should be able to see that the vertex here is going to be negative 1 over and 2 up. The domain then is going to be, like we said before, negative infinity to infinity. I can see this arrow is pointing here and it's never going to stop. This arrow is going here and it's never going to stop. And so negative infinity to infinity is our best bet with that one. The range then, in this case, we're starting from a bottom point and we're going up. And so that would mean that my range would start at the y value of 2, which is included, and it's going to go up forever. And so again, we can check 1, 2, 3 of our ideas here, or our places that we're approaching are infinity, and then the 2 is going to be the included point or the included coordinate of our y value that we're working with there. And then we have our interval of increase and decrease again. And so with this one here, if I start at this point and I move over to the right, I'd have to go down again to get to this point here. If I move to the right, I have to move down. If I move to the right, I have to go down. So everything up to my vertex on this one is going to end up being interval of decrease up until I get to that point right here. And it's not quite to that point there, but it's everything in front of it. I think we got a good enough idea with that we will, if we're talking about x values, our interval of decrease here is going to be negative infinity up until we get to the point of our x value of -1, the x value of our vertex, which we can see up there. Once we get to this point here, we are going to change what's going on. And it's trying to read those lines for me. So I'm going to do this, try to outsmart it a little bit. Come from the top. Yep. So after we get from our interval of decrease, we switch over to increase. And so it's going to be anything past the point of -1 for my x value. And it's going to go up to infinity. So notice that every single point, except for -1, is included in that list there. If we're not going down, we're going up, unless we're at -1, and then we're not going up or down, we're just stationary. So that's the idea of the first page. You'll do a couple of practice problems like that. There's one more thing they want us to talk about, or at least we're going to, just kind of look it over. We're not going to do any solving here, but it's talking about solutions in a problem. And so they actually solved by factoring over here. They did the steps that we talked about. They actually did the AC method, solved it all the way through, and then they found their two solutions. Now, the graph that we were talking about here is the x squared minus 4x minus 12, which is the same graph that we're talking about over here. So the solution was -2 and 6. And if I come over to my graph here, I can see -2 and 6 are the 2 points that cross that x-axis. So how is the graph related to the solution? The solutions are where we cross the x-axis. So it's going to be the x value of that point, because obviously the y value is going to be 0 there. So -2, 0, 6, 0 would end up being our points, and we can find that by factoring, by graphing, quadratic formula, sometimes square root method, depending on the problem, but that's the idea behind it. So you are going to try 2 of these: vertex, domain, range, interval of increase, interval of decrease, everything we talked about on the front page. And then all you have to do is pick out your solutions. When we pick out a solution, so on this first one, I should be able to see that there's 2 solutions here. We want to say x equals whatever our first number is. And again, it's not going to be hard. You're not solving here. You're just picking it out on a graph. You're identifying a number. So all you would have to say is x equals your first number, and you'd say x equals your second number. And then on the next one, you could kind of do the same thing. Okay, so that's where I'm going to leave you. You just have these 2 problems to try. Once you're done with them, then you're done with what is expected of you for the day.